All right, well, thank you, everybody, for coming. Let me recognize a few folks who are with us before I get started. From the Metro Council, we have Council members Hunt, Gilmore, Pridemore, Stein, Westerholm, and Allen. I thank them for being here. We also have Council Director John Cooper. We have our head of codes, Terry Cobb, and Tommy Lynch from our Parks Department. Thank them all for being here. Now to why we're here. Nearly 5 years ago, Nashville suffered a devastating flood. 11 people died. There were $2 billion worth of property damage throughout the city. Many businesses closed or lost revenue. Some neighborhoods were forever changed. And our downtown, the cultural heart and financial engine of Nashville, was underwater for a few days, a stunning sight that temporarily silenced the beautiful music at the Schermerhorn Symphony Center and slowed the busy pace of the Bridgestone Arena. Downtown Nashville has come a long way over the past 25 or 30 years. It used to be a place many people avoided, a place where adult businesses were the norm, not the exception. Now downtown is a huge part of our city's success, a place where residents and visitors from around the world want to go for music, sports, art, food, historic sites, a great public library, and more. Our Lower Broadway Entertainment District is like no other in the world, and the Bridgestone Arena just recently won the Pollstars Arena of the Year award. But if all that took a big hit in May 2010, and we don't want that to happen again. We want downtown to be safe from the rain, safe from the Cumberland River, the same river whose banks we've been working hard to redevelop with green space, activities for children, and coming this summer, a new concert venue. I'm pleased to announce today that Metro Water Services will build a flood protection system that will guard downtown from a flood even more powerful than the one we battled 5 years ago. This $100 million project, which the Metro Council approved in the capital improvement budget last year, will give the city, downtown residents, workers, business owners, and visitors a new sense of security about the streets and buildings they love. While the cost is significant, it's small compared to the price we would pay if the river swelled over its banks again and flowed into downtown. That price would be even higher than the one we paid in 2010. Back then, downtown didn't have the Music City Center, the Omni Hotel, or the expanded Country Music Hall of Fame and Museum, which expects to have 1 million visitors this year. Downtown also didn't have restaurants like Etch or the Southern 5 years ago. The risks to all of these places are higher than many people think. In August 2013, another major flood dumped even more water on Madison than downtown saw in 2010. So I look at this downtown flood protection system as an insurance policy. We're going to pay a premium so we can reduce our risk of catastrophic flooding in the heart of our city. We're making an investment in downtown that will pay for itself with the protection it will provide, the people it will keep safe, and the businesses it will keep in operation if our typically peaceful river rages over its banks again. We have spent a lot of time, effort, and yes, money on protecting other parts of our city since May 2010. We've improved the Metro Center levee. We bought and demolished 225 flood-prone homes in neighborhoods like Pennington Bed, Bordeaux, Mill Creek, and the Nations. We've taken the land that sat under those vulnerable homes and turned it into open space. Those green spaces add to our quality of life on a normal day and help soak up water whenever there's flooding. We've also developed the Nashville SAFE program, which makes it easier for the city to monitor river levels and dispatch resources to deal with flooding across the city. And the online NERV tool provides information to the public during any disaster or emergency. And those are just the highest profile projects. All told, Metro's investments outside the core of the city has totaled $127 million. Now it's time to make sure downtown is safe too. Nashville is constantly changing, like the river itself, but the river will always be with us, and we have to protect our assets from it at the same time that we celebrate it. My time as mayor will be winding down in 6 months or so. It's important to me to get this project off the ground before I leave. The flood of 2010 gave our city a shock during my first term. We bounced back strong, largely because we all took care of each other and lifted one another above these challenges. But I don't want the next mayor or another one down the road to have to worry about keeping downtown safe if another flood comes along. There's just too much at stake. Scott Potter, the Director of Metro Water Services, will now give a detailed presentation about the downtown flood protection system. A community meeting about the project will be held from 3 to 5 p.m. on March 3rd at the Nashville Downtown Partnership, 150 4th Avenue North. Thank you. Scott?
Thank you, Mr. Mayor. Good morning, everybody. We've got a detailed presentation to talk about. I'm going to ask you to, on occasion, to pretend you're a water drop to help you understand what's going on with the project. And if you would, please hold your questions until the conclusion of the presentation, and I will go into great detail with any questions that you may have. We're here to talk about the downtown flood protection system. First, I want to start with a video to help us remember what happened in May of 2010.
It was a natural disaster not seen in 1,000 years.
The flash flood caught Nashville, Tennessee off guard, drowning the city's downtown in the flooded waters of the swollen Cumberland River.
A vengeful storm that devastated a modern American city in just 36 hours.
President Obama has declared a disaster area in 10 Tennessee counties.
From the beginning, this spring storm on an otherwise normal Saturday seemed different, more intense, more deliberate. Experts said it was a stalled frontal boundary coupled with moist air from the Gulf. To Nashville residents, it just seemed angry. Before it was through, 10 Nashville residents would die, succumbing to floodwaters they never could have imagined. In Nashville alone, damage estimates started coming in at close to $2 billion, almost equal to an entire year's economy for the city.
A lot of the buildings I happen to be involved in downtown were heavily damaged, the Skirmahorn being the main one.
More than 2,700 businesses were forced to close temporarily or permanently because of flood damage, affecting almost 15,000 employees and resulting in lost revenue of almost $4 billion.
We have an event that many cities could not have survived through its government, through its civic leadership, just the initiative from our wonderful mayor. Nashville has done things that other cities just dream of.
Since the deadly weekend of 2010, Nashville has experienced a renaissance that truly is the envy of other cities. Record growth, a new spirit, and a national buzz have catapulted the city to new heights. But to those who survived those 36 hours in May of 2010, the memories of the flood are never far behind.
This map here is an accurate representation of what happened. As Director of Metro Water Services, I'm obligated to protect downtown from that happening again. Talk about what the mayor said, reinforce it. We had $2 billion in damages, almost $4 billion in lost revenue. Key thing about downtown, obviously, is experiencing significant growth. Since 2010, we've had $1.2 billion in permits. We've got a 15% growth rate for people living downtown. We need to protect downtown, like we've done outside of downtown. So what have we done since? Key thing to note here is we started this process and this project in the summer of 2010. This work has culminated in a design that I feel very comfortable with proceeding with. It started with a unified flood preparedness plan. We initiated this in February of 2011, and one of the things it talked about was the cooperation of the partnership. Metro Water Services has not done this alone. We work with the Corps of Engineers, with USGS, and with the Weather Service. A lot of partners locally and nationally to develop the preparedness plan, one component of which is the downtown flood preparedness protection system. We had 22 damage centers identified in the UFPP. Downtown was one of them, and it spoke specifically to a flood protection wall and a pump station. So What I'm presenting today ties directly back to the UFPP. The Sobro Master Plan, the next major plan that was associated with downtown, tied directly to the UFPP. The Sobro Master Plan had a flood protection element. That led to the West Riverfront Park Plan, which also tied to the Sobro Master Plan, which tied to the UFPP. When we announced the West Riverfront Park project, the mayor specifically mentioned the 26-foot wide promenade that had a flood wall component associated with it. Like I said in this photograph, this represents what happened in downtown during the flood. So you can see all the way up to the Music City Center, a lot of downtown is underwater. This project will correct that. Okay, so I'm going to go into great detail about what we're going to do to prevent the downtown from flooding again. But one of the things I want to do first is talk about some history. If you look at this line here, that's called the First Avenue Tunnel. I'm going to talk about that. I'm going to talk about the 12-foot 6-inch Wilson Springs Storm Tunnel and the 84-inch Wilson Springs Storm Sewer. Okay, the Wilson Springs Sewer. In the 1880s, we had issues with sewage causing significant health issues in Nashville. So the Wilson Springs Sewer was constructed out of a stream bank. It was the first major drainage project in Nashville, but it was also a sewer. So it was a combined storm sewer and sanitary sewer. It was constructed over the Wilson Springs branch, which was a stream. So that's an 84-inch sewer that we've got to work with in this project. The second is the Wilson Springs Storm Tunnel. That's a 12-foot, 6-inch horseshoe-shaped drainage system that was built in 1967 to alleviate flooding in the Wilson Springs drainage basin. So the first component is the flood wall, and that's going to be the easiest thing to kind of visualize. It's going to run from the Riverfront Park just south of KVB. Good place to look at it here. It'll start in the park where this orange is. It'll go into the park and then pick up on First Avenue and go up to just south of Fort Nashboro. The First Avenue Tunnel is this blue line here. That was constructed in 1950, in the 1950s. The Wilson Springs Storm Sewer that came down from 8th Avenue Reservoir carried sewage. In the late 1940s, the Corps of Engineers constructed the Cheatham Dam. That precluded the use of the Cumberland River as a sewage disposal function for the city. So the city decided to build the Central Wastewater Treatment Plant, which is at the end of 2nd Avenue. We intercepted the flow from the Wilson Springs Storm Sewer and took it to the Central Wastewater Treatment Plant. So we've got the Wilson Springs Storm Sewer, the Wilson Springs Storm Tunnel, and the First Avenue Tunnel. Okay, here's the flood wall. So this is the park under construction presently. It starts right here, and this is permanent. So within the park is permanent flood wall. I'll show you later in the presentation, this is going to be temporary as far as what we construct in the event of a flood, but we'll have permanent markers. These will be permanent, and then we'll install these. And I'll show you how that works later in the presentation. These are the permanent structures. And this is how the flood wall is going to be constructed. So the good news is that will take a Metro Water Services 10-person crew about 8 hours to construct. If you recall, during the May 2010 event, we had plenty of time to do that. Also good news is that that technology is not cutting edge. It's used all over the world, especially in Europe, and also at Gaylord Opryland Hotel, that's presently already constructed and in use to protect the Grand Ole Opry and the hotel. So this technology is proven. And if we have a river event of the magnitude of May 2010, this is well suited and well able to withstand the static pressure of the river against that flood wall. So we can construct that in 8 hours. So this is a side view. Okay, this is the permanent part. This is the ground. This part here is below grade. So that's constructed anywhere from 10 to 30 feet into the ground. Key thing is we've got hydraulic pressure here. The river's trying to go through our karst rock. You've heard people talk about rock that has like holes in it. The water can migrate underground underneath the wall, so part of the construction will be to construct the underneath the ground part of the flood wall, anywhere from 10 feet deep to 30 feet deep. All right, so over the course of the presentation, I'll talk about how much this is going to cost. Like the mayor said, it'll add up to about $100 million. This is $13 million. Next. Next. Okay, so now what I'm going to do in this graphic is I'm slowly going to build the system and show you what has happened. So now the flood wall is constructed. This is the area that was flooded. Next. And I'm going to show you, as we go along the presentation as well, what happens to the floodwater during May 2010. So at this point, here's the river, here's the flood. Please note, we've got the flood wall constructed, but nothing has changed. The reason why is we've got hydraulic connection. That means a water molecule, a piece of the river, can get from the river to downtown through one of those two storm sewers and the First Avenue Tunnel. So we haven't done anything at this point to correct the flooding, but the flood wall is part of the entire solution to complete the system. Okay, next. All right, now I'm going to talk about the Wilson String storm system. And I want to talk about how the drainage systems work. This is 8th Avenue Reservoir. There's 8th Avenue going all the way from downtown. If you're a drop of water and you fall out of the sky and you land anywhere in the red, you're going to get from wherever you land to the river. And the key part about this process is if you're going to land here, you're going to the river. All we're going to do is control that water a little bit better to prevent it from harming downtown. So I've still got to get you to the river. There's the outfall. So if you're on the river just to upstream of KVB, you can see both of those outfalls. They're about right here. All right, so now we've got to take the storm tunnel, that's the 12-foot, 6-inch horseshoe-shaped tunnel, and the storm sewer, which is the 84-inch storm sewer, and we've got to plug them. So by doing that, we isolate the river from here to here. So if there's a plug here and a plug there, that means the water can't back up into downtown. Okay, that's going to be a $4.8 million construction process. Okay, so now I've got the flood wall constructed, I've got the storm sewer plugged, and I've got the storm tunnel plugged. Now I've got to take care of the First Avenue Tunnel. Okay, the tunnel goes from the Driftwood Basin, which if you guys think about where the MTA parking lot is, that's the Driftwood Basin. The First Avenue Tunnel, which was tunneled in 6-foot diameter all the way to just to the downstream side of Gay Street. So this this First Avenue Tunnel has a hydraulic connection to the river as well. So we've got to isolate that. So we've got to construct two flow control valves at the downstream side and the upstream side. The key thing about this presentation slide is it's 55 to 65 feet into the ground. There's a person standing on a catwalk to kind of give you an idea of scale. So we've got to get all the way through all this rock because this was bored. This was hand bored essentially back in the 1950s. So we've got to get all the way down dig a giant hole essentially and install 2 flow control valves. I'm going to talk about the points of failure in the system and how we mitigated it. One of the things key about this structure is there's 2 valves. They're electrically operated, but we have an opportunity to operate them by manual operation as well. So we've designed a lot of fail-safe things into the system. Next. All right, so now let's go back to where the fundamental design. There's a First Avenue tunnel. That valve is closed, and that valve is closed. So I've got a 6-foot diameter pipe that's hydraulically isolated from the river. And what that means is the river cannot get into the tunnel, and if the water doesn't get into the tunnel, it can't back up into the city. We've isolated the storm tunnel, we've isolated the storm sewer, and we've built the flood wall. The First Avenue tunnel flow control structures are $18 million. Okay? This graphic So this graphic, that flow control structure is closed, that's isolated, and the flood wall is up. Next. Now we've made it worse. Okay? Now here's why. If you're a water drop and you land in that 580-acre drainage basin, you're going to come down the hill and you're going to hit the wall. You're going to collide with the flood wall coming downstream. So what we've done is we've isolated the city from the river, and we've isolated the river from the city. So now we've got to get all this water essentially over the wall to get to the river. Next. And that requires the most expensive component of the system, which is the stormwater pump station. So if you remember the first slide I said, we had a 580-acre drainage basin. That was with the Wilson Springs Storms Tunnel and the Wilson Springs Storm Sewer. Once we isolated the First Avenue Tunnel, we added an additional 100 acres of drainage basin to the area that's required to be drained by the pump station. That's going to require the pump station, which is represented here, just to the upstream side of the Siegenthaler Bridge. This is not what it's going to look like. That's going to be the basics of the pump station. So if the engineers were building it, it would look like this. Fortunately, it'll look like that. So this will be a component of the park system. This will be an area that people can walk out and look at the river. These right here are the exit points for the pumps. This right here is where the water is going to flow out of the Wilson Springs Storm Tunnel and the Wilson Springs Storm Sewer on a day, if it's in May and it's not raining cats and dogs, you land up near 8th Avenue Reservoir and you're a water drop, you're going to end up right here. In May 2010, you're going to come out of one of these holes. The key thing is we've got to get you over the wall, because if we don't do that, we make the downtown flooding worse. Okay, I talked earlier about the single point of failure and how we design redundancy into the system. This generating facility will be available for the pump station. Right now, if we were to build the system without the standby, we'd have really good redundancy. We'd have 2 feeds from NES going to the pump station. To me, that's not enough. We need to have a standby source of power just in case we lose both NES feeds. Good news is during 2010, in May, we didn't lose power, but we might. So to mitigate what I consider the biggest source of concern for me, we're going to partner with DES to construct this standby power facility. So most of the time, hopefully, a significant part of the time, DES is going to use it for power, but in the event of a May 2010 or 2-foot worse event, we've got standby power available, which will be available to us to use to operate the pump system. That really increases the cost of the system. The stormwater pump station is $65 million. That's because it's significant pumping capacity. All right, so let's review. Let's go back to the main schematic. Here's the First Avenue tunnel. That's the downstream flow control valve. I'm sorry, that's the upstream. That's the downstream. Those are closed. The flood wall is up. Both the tunnel and the sewer are isolated. And now the pump station is constructed. And now we've completely isolated the system. So, I think one of the things to discuss at this point is what will happen in the event of a flood to the east side of the river. We need to change our presentation to this one, so we're going to do that real quick. And I'm going to talk about how the river behaved during the flood, and I'm going to talk about how the river behaves on a day like today when it's not flooding, to kind of give you an idea of what happens to the east side once we've done the work on the west side. All right, so on a day like today, the river's up a little bit, so let's just make this June or July, a normal day in the river. So we've got the elevation at 385. There's the river level, and it's moving at about 4 feet per second. Okay, May 2010, that's 385, that's 419. So when we talk about the river peaking at 51.96, that's the difference. Here is the east bank, and that is storage, and that's the west bank, and that's storage. During the flood, we were moving 1.4 million gallons a second down the river. And it was moving at 6.7 feet per second. On the west bank, it's barely moving. On the east bank, it's barely moving. And you've heard me talk a lot before about floodway and floodplain. This is floodway, and that's floodplain. So we've got storage here and storage here. That's the graphic about what happened. Okay, we got the flood wall up. Here's the key part to understand. We're not putting more water on the east bank. All we've done is taken this storage away from the river. When we construct this project, we take the storage that's represented in that 680 acres, and we move it on the other side of the river, on the other side of the flood wall, and we spread that water out all over the entire drainage basin. Does that make sense? Okay, so what that does is it takes 1.8 million cubic feet and it puts it into 382 million square feet of storage. So that's the water that's got to be displaced into the entire drainage basin. So we're not putting more water on the east bank. The river is going to move a little bit faster, and it's going to increase the depth by 1/16 of an inch. Now that sounds hard to believe, but the hydraulic modeling and the computer modeling prove that conclusively. It's only going to raise it by 1/16 of an inch. And the way to an analogy is, you've got a kiddie pool here that's full of 4 feet of water. It's like adding half a gallon of water to it, and that is going to raise the half gallon into 100 gallons. It raises the kiddie pool by 1/16 of an inch, which is the width of a nickel. So now the west bank storage is gone because we've gotten it on the other side of the flood wall, and it is on the east bank, but it only raises it by 1/16 of an inch, and the flow rate goes up by 0.4 foot per second. I think that's a difficult thing to really kind of understand, but the summary is we're only removing storage from the west bank. We're not taking water and putting it on the east bank because the water has to get there anyway. So that concludes my presentation. I guess I'll open it up for questions at this point. Before I do that, I want to introduce some people in the room that are part of the project. Larry Adama, the project manager. Casey Cooper, the project engineer from Metro Water Services, and Shannon Lambert, the project engineer and the lead engineer from Barge Wagner Sumner Cannon. So please, if you have any questions, please ask. Yes, ma'am.
Bottom line cost, I saw a lot of figures, add them all up.
It's $100 million. We're completing design. The design will be complete by midsummer, and we'll start construction accordingly.
Is this a project that needs council approval, or what's the process?
The council approved the $100 million line item in the capital improvements plan of 2015.
Is it paid for by sewer fees, or?
It's a Metro Water Services project. So it's water and sewer revenue.
Do you have to raise sewer rates?
We've got the bonding capacity to hold this project. So one of the things to recognize is we're not taking $100 million in cash and paying for it. This project will have an indefinite lifetime. So we're going to bond it over 20 to 30 years. So that will result in a debt service payment between $6 and $7 million a year. So the mayor referenced earlier an insurance policy. So essentially, it's a $6 to $7 million insurance policy to prevent several billion dollars worth of damage downtown in the event of a flood. To me, this is personal to me. I feel obligated to bring forth this solution. I'm comfortable in the design, and I'm convinced that it will work.
Is the wall permanent or temporary? That's the piece I was not clear about.
Okay, if you look at this here, all right, the orange, I guess I can use my finger. Okay, here's the flood wall in the park. That's permanent, and that's incorporated into the design. And the good news is you really won't notice that it's a flood wall because it'll look like a place to sit down, because it will be a place to sit down. This part from just south of the Siegenthaler Bridge to Fort Nashboro will be temporary in that these posts here, these will be there all the time, but they're architecturally significant and they're really pretty. I mean, the lighting will be striking and they'll be incorporated into the beauty of the park. So the promenade will have these, but when we need to, we'll install these aluminum slats. It's not complicated, and that's the key thing in designs that I support is simplicity and provability. We're not doing anything that's cutting edge. The technology, all the valve systems, the wall, the pump station, it's all, I don't want to say old technology, but it's proven technology. This system will work. One of the things that may follow from that is, can we construct part of it now and maybe delay part of it to later? We really can't, because each component is equally important. And the whole system won't work unless you have all the components in place.
How long is the permanent part of the flood wall, and how long is the temporary part of the flood wall?
I've got that. What was the number?
Shannon? 1,200 feet of temporary or removable flood wall, and then 900 feet inside the park.
Did you say 1,200?
1,200 is permanent.
No, that's the temporary.
1,200 is temporary, 900 is permanent.
And that's 900 feet, 1,200 feet.
Yes, ma'am. Yes, sir.
I would guess that someone from the Titans, someone to ask these questions these days, would say, okay, what does this mean for our stadium? Because I know that we had about 6-7 feet of water in there, and our entryway down there was all flooded.
Understood. And I personally briefed representatives of the Titans yesterday, and understandably, they were concerned about the effect on the stadium. When I showed them the part of the presentation that showed the river level going up by 1/60th of an inch, they were somewhat comforted. They weren't completely comforted because they wanted to know, what are we going to do on the east side? Well, the key thing here is I'm going to work on the west side, get that fixed, and then study the east side and see what we can do. So we're not done. If you think about what we've done since 2010, this has been a continuum. We haven't stopped, and we never will. We're always going to try to improve the flooding mitigation situation countywide. And that's key as well. Almost all of our work at Metro Water Services for flood mitigation has been exclusive of downtown. We've taken out 954 tons of debris out of the First Avenue tunnel. That's a lot of stuff. But other than that, when you get out of downtown, $127 million has been spent outside of downtown for flood mitigation. I'm obligated to work on downtown as well.
And kind of going down the river a little bit, down to where those other businesses across from J Street, the oil terminals, whatever that is there, and on down, Nashville Concrete, et cetera, et cetera. Have they been briefed, and have they had questions, okay, what about us, and will this affect?
We're going to brief them at the public discussion that was advertised earlier today. So
tell them they'll only go up 1/16th of an inch as well?
Yes, sir. It's 1/16th of an inch. And I know that sounds hard to really believe, but we're sure. And the modeling...
Backup of the water that came up like downtown, I thought it came up similarly under the stadium and also in those businesses on the east side there, up from the truck terminal.
The East Bank, this project doesn't address the East Bank. It's just that simple. We have to do a study and a project on the East Bank as well. Key thing is this solves the West Bank May 2010 flooding problem, and it solves it with technology that is proven. Yes, sir.
How about Germantown? Would this push the risk of flooding further downstream to Germantown?
It doesn't. If you look at, let's see, Sonia, can you try to find the graphic that shows, yeah. It's kind of difficult in this setting to talk about different elevations, but this doesn't impact the West Bank either outside of the confines of the projects, because the elevations that we talk about in this project are specific to the drainage basin associated with the Wilson Springs branch. So if you go back in time again to 1880, there used to be a stream that's now a sewer that's now intercepted by the First Avenue Tunnel. So all that drainage basin is what we're controlling. So when you get out of that drainage basin, we're not designing or constructing a facility to influence that drainage basin. Shannon, you okay with that? Okay.
Yeah, prior to the 2010 flood, I mean, did you ever realize that downtown was at risk for this sort of flooding? And take us from, again, that timeline of the flood happening and then the sort of timeline you went down in terms of studying this and figuring out this is the best plan.
All right. One of the things that I guess I operate from a position of, as an engineer, I can almost fix anything. I can't guarantee 100% conclusion on everything, but when I saw the problem, which was downtown underwater, I knew that we could mitigate it to a point. So in the summer of May 2010, we started talking with the Weather Service, with the Corps, with USGS. If you think about SAFE and NERV and all that stuff is connected to this project, because the UFPP has led to SAFE, which led to NERV. The UFPP led to the home buyout. The UFPP has led to this project. This is one of 22 damage centers. Downtown is one of them. We've connected the entire process, and we haven't disconnected anything from the flood mitigation. Everything we do at Metro Water at this point has a flood control component to it. Even philosophically about supporting the council legislation about floodway construction prohibition. It literally is all connected. Nancy, you had a question?
Yeah, if you were to look at something for the East Bank, what do you think it would be like? Would it be something as complex as this?
I think it'd be similar, but not as complex because the drainage basin isn't as significant. It would have a flood wall element and a pump station. The best thing to think about there is Metro Center levee. During the flood, that levee and that pump station designed to spec. So that's what we're doing here, is we're building a levee. It's just going to be not made out of earth. And we're building a pump station, which already exists at Metro Center levee. So it's a similar design, but we haven't specifically addressed that one yet. It's part of the continuum. One of the things about my job is tomorrow we'll introduce another problem. So whoever succeeds me and the person who succeeds that person is going to be talking about flood control, water infrastructure renewal, sewer infrastructure renewal. We're never going to stop trying to mitigate flooding. Yes?
You said a wall like this already exists around Opryland, is that correct?
Well, it's a design similar to this. It's not exactly the same, but it's the same concept. It's a wall that has permanent elements and temporary elements with a pump station. And I haven't seen it function. I've seen the construction, and I've seen the permanent part, and I've seen the pump station, and I've talked to the engineers that designed it and built it. It'll work. So it was prudent on their part, I thought, and we're doing similar things with our project as well.
And again, you said this will start this summer?
We're going to finish design this summer. We've got 30% design complete. We're finishing design, and we should start construction, I would say late summer, midsummer to late summer.
And the $100 million sounds like that's for the downtown part of this that you've been talking about. And then you mentioned the $127 million that's being spent outside of downtown. So we've got two separate.
Well, that 127 represents what we've invested since the May 2010 flood, and it's most of it is, not most of it, but a lot of it is the 225 homes that we bought out, the Metro Center pump station improvement. A lot of projects have been done exclusive of downtown to mitigate flooding.
So that's already been spent?
Yes, ma'am.
Okay.
Yes, ma'am.
Will this include a lot of permits from the Corps and water quality permits?
We've been working closely with the Corps on this project. We've got the permit review presently occurring for the pump station, but every indication I've gotten from the Corps indicates that they're good to go with how we're going to proceed. They had concerns about navigation. We talked to the Coast Guard about that. We don't see any issue with permitting on this project.
Water quality including?
Yes, ma'am. Yes, sir.
Is this the single largest sort of flood control project you've ever taken on?
At this point, yes. I mean, if you look at the flood mitigation project associated with the home buyouts, I think that's 88 million total. I'll get you the exact number on that, but it's significant from a one project perspective, and the size of this project exceeds any flood control project that we've done at Metro Water Services.
And as far as paying for it, I mean, I understand a bit how bonding works, but I mean, does this mean you can't do some other things? I just have a hard time believing that it doesn't really have any effect or won't raise rates somehow.
Well, we've got the bonding capacity presently to do this project. Like I said, it can be anywhere from $6 million to $7 million a year for debt service. We have the ability presently within our rate structure to absorb that.
Are the people on the East Bank, it sounds like, are they going to be left vulnerable? They're not the priority, or what, what do we say to those people?
Well, the message and the reality is we're not changing what happened on the East Bank. And what I would say to them is the SAFE tool, as an example, was designed specifically to forecast that this is going to happen. So right now, in real time, I have the ability to tell the mayor what areas of the city are at risk for flooding on our major tributaries and the Cumberland River. So the SAFE tool, which was developed first in the UFPP, will be able to tell people along the East Bank that there is a flooding risk coming, and we can get really accurate as far as the depth and the time so we can do evacuations if necessary. So if you think about what we did first, is we protected the whole county first with SAFE. Then we did the home buyouts outside of downtown, and now we're coming downtown. So the East Bank is not, being ignored. The message here is we're not making it worse, that it's one step at a time. Yes, ma'am.
Anticipate acquiring any property or land downtown to facilitate the project?
And that's the beauty of this. No, is the short answer. We've got the pump station good to go. Obviously, this part of the flood wall is in the park. That's on right of way. And the Demonbreun control structure, which controls the flow here and here, we already have. So we can proceed. I want to thank you all for coming. I'm very excited about this project, and I'm convinced that it will be successful. Thank you very much.